In this experiment, we are going to be determining the relationship between the concentration of sugar in a solution to the solution's density.
He is in the appropriate lab attire. He is wearing his goggles, long sleeves, long pants, and closed-toed shoes. For this experiment, we're going to be using a pipette and its bulb, a beaker full of solution, a beaker full of blue water, and a 50 milliliter Erlenmeyer flask. To prep our pipette, we will wash it out with water 3 times. After washing out your pipette with the blue water 3 times, you will now wash it out with the solution for 3 times. Now we will get our stock solution and pour it from the main container into a beaker. Be sure to pour your solution into another container to use for pipetting, and never pipette straight out of the container. Here we have our stock solution. It has a 20% sugar concentration. It will now be used to be diluted into our diluted solution. We are now going to measure the empty 50 milliliter Erlenmeyer flask. The mass of the empty Erlenmeyer flask is 41.047 grams.
We are going to begin by transferring some of the 20% sugar solution into the volumetric flask using the pipette. Squeeze the bowl before applying it to the pipette and make sure that the solution never enters the bowl. Put your finger above the hole so that the water stops flowing out of the pipette, and then hold it at eye level and read the volume at the bottom of the meniscus. So this looks like it is right around 6.51.
We can see that this person is looking eye level at the curve of the meniscus. We can see how the water molecules are attracted to the glass molecules, which causes this curve, which is the meniscus. So, in the measurement with something that has a meniscus, you always start your measurement at the bottom of the meniscus. In this case, it's 8.35 milliliters. This is a visual example of the meniscus. When reading it, be sure to hold it at eye level and notice how the water adheres to the sides of the pipette.
And then let it flow into the volumetric flask.
Read the meniscus after transferring the solution to the volumetric flask, or in our case, the Erlenmeyer flask. We are now going to dilute it to the 30 milliliter mark with the water from the pipette. We have now reached the 30 milliliter mark of our diluted solution. Here we have our diluted solution. That's when we add water to decrease the concentration of the sugar inside the original stock solution. We are now going to find the mass of our diluted solution. If you have extra solution, offer it to a neighbor.
Do you guys need more solution?
Yes, please.
But in the case that your neighbor does not say yes to your offer of the extra solution, you need to dispose of it instead of pouring it back into its original container. Wash and clean all leftover materials and glassware. Once you're done, clean up your workspace.
These are the values we recorded in our lab notebooks, but to demonstrate the calculations, we will only be using the data from trial 1. We began by weighing the empty Erlenmeyer flask, which gave us our initial mass. We then grabbed the 20% stock solution, which gave us our initial concentration value of 20%. We put 5.55 milliliters of stock solution into the flask, which was our initial volume. We then filled the flask the rest of the way up with water until it reached the 30 milliliter mark. This was our final volume. The only variable we did not know yet was the final concentration of the diluted solution, so we just brought the variable down. We then weighed the filled flask to obtain our final mass. Using the formula final minus initial, we calculated the actual mass of the diluted solution. With mass and volume, we could calculate the solution's density, since density is mass divided by volume. After inputting our values and dividing, we had obtained our first desired value, which is this diluted solution's density. Next, we moved on to calculating the percent concentration. We multiplied on the left side of the equation and divided both sides by 30 to obtain our final percent concentration of the diluted solution. After obtaining density and percent concentration, we plotted these values onto a graph, which shows the relationship between the concentration of sugar in an aqueous solution with the solution's density.